Alright, now we're going to discuss the topic of 30, 60, 90 triangles. So we just discussed the beautiful 45, 45, 90 triangle. Simple, elegant, yet so beautiful, in fashion this spring. So keep in mind, notes that I showed you guys last time, I solved triangles for similar triangles for missing sides by doing ratios of corresponding side over the corresponding side. So let's continue on. Now notice, here I have an equilateral triangle. If a triangle is equilateral, which means equal sides, then it is also equiangular, which means it has equal angles. So if I were to start off with this, that means each of these is 60 degrees. And if I were to divide a line right down the middle, I would get a 90-degree angle, and half would be 30. So I'd get a 30, 60, 90 triangle. Now, I identified a 45, 45, 90 triangle as the sides being 1, 1, square root of 2. The 30, 60, 90 triangle is a little bit more tricky. Just a little bit. Okay? So notice, I have here a 30, 60, 90 triangle. Now, remember when I started talking about triangles at the beginning of our sections about triangles, we identified that across from the smallest angle is the smallest side. Biggest angle, biggest side. That's going to become very important here. Across from the 30-degree angle is the smallest side of 1. Across from the biggest angle is 2. That's pretty easy. The one that's a little bit trickier to remember is across from a 60-degree angle is square root of 3. So I have a 1, 2 square root of 3 triangle. And the biggest, easiest way to remember this is put the 1 across from the smallest angle, the 2 across from the biggest angle, and the square root of 3 across from whatever's left, which is the middle-sized one. Alright? So to solve these, we're going to go through them the same way that we solved my 45, 45, 90 triangle. I'm going to draw out a second triangle next to it. So if this is 60, this is 30. So I'm going to say 30, 60, 90. I'm going to label it 1, 2, square root of 3. So I have, if I'm going to solve for LM first, this over here, I have 14 is to x as 2 is to the square root of 3. Make sense? Okay. Once again, I have my hypotenuse over the leg that I'm solving for. Remember, hypotenuse is on top, legs on the bottom, or you can do legs on top, hypotenuse is on bottom, as long as you keep them the same. They must be the same. So I'm going to cross multiply. 14 times the square root of 3 equals 2 times x. Now, how do I get x by itself if I'm multiplying it by 2? That's right. I divide by 2, divide by 2. X equals 14 divided by 2 is 7 times the square root of 3, which means this side over here is 7 times the square root of 3. Very simple. Okay, I'm going to put y down here just for the sake of having a different letter. So I'm going to say 14 is to y as 2 is to 1. Cross multiply. 14 equals 2y. Divide both sides by 2. Y equals 7. And you're done. It's that easy. Now, something very important I want you guys to notice. I want you to notice that I have this side here, the hypotenuse, is twice the smaller side. So if I had looked at 14 and say, what's half of that? Well, it's going to be 7. Okay, makes sense? Now look at this one. To get from here to here was just half of it times the square root of 3 from the hypotenuse to the leg. Which makes sense. If you take half of 2, that's 1, times the square root of 3 is just the square root of 3. Just a little trick to help you figure it out if you can think that way. Turn the page. Now I have 2 times the square root of 5. So I'm going to draw out my 30, 60, 90 triangle to be 1, 2, square root of 3. I have 2 times the square root of 5. So I'm going to take, to first find LM, which is this side over here. I'm going to say 2 times the square root of 5 is to x as 1 is to the square root of 3. When I cross multiply these, I get 2 square times the square root of 5 times the square root of 3 equals x by itself, because 1 times x is just x. Remember, when we have radicals and I multiply radicals together, they radically just combine inside their radical. So I get 2 times the square root of 15 equals x. And I'm done, just like that. Now, something that I noticed, just to point it out, to get from here to here, I multiply by the square root of 3. So that's exactly what I did here. I took this side and multiplied it by the square root of 3. If you can remember to do that without doing anything, you're good to go. If you can't remember to do that, set up your ratios. The ratios will guide you every step of the way. Let's put y in for my missing side now. So I'm going to say 2 times the square root of 5 is to y as 1 is to 2. Now remember, I've got my hypotenuses and my legs. They're both either denominators or the numerators. That's very, very, very important. Cross multiply. You get 2 times the square root of 5 equals y. You get 4 times the square root of 5 equals y, and I'm done. Now notice, once again, from 1 to 2 you multiply. 1 times 2 equals 2. If I'd taken this, 2 times the square root of 5, multiplied it by 2, I got right back here. And that's exactly what I ended up doing. Except here I just set it up in a ratio. Once again, if you can remember the trick, you can use it. If not, the ratios will always be your guide. Problem number 3. Let's set up my triangle. This is my 60, 30, 90, 1, 2, square root of 3. So I'm going to say, when I'm solving for Ln, my hypotenuse, I'm going to take 8 is to x as the square root of 3 is to 2. Okay? So now I'm going to take this, I'm going to cross multiply. 16 equals x times the square root of 3. Uh-oh, I need to divide by the square root of 3. And I have x equals 16 divided by the square root of 3. Now, class, can I leave it like that? No, you're absolutely right, I can't, because I've got a radical in the denominator, and that's just too radical for me. Get it? Radical, radical. Okay. Multiply top and bottom by square root of 3 over square root of 3. I get 16 times the square root of 3 divided by 3. And that gets me my answer. Next I'm going to take 8 is to y as the the square root of 3 is to 1. Okay, so now I'm going to take this right here, and I'm going to multiply it, cross multiply and divide. 8 equals y times the square root of 3. Once again, just like I did before, divide by the square root of 3, divide by the square root of 3. Y equals 8 divided by the square root of 3. Can I leave it there? Nope, just like I did there, I do here. Divide and multiply. Multiply by square root of 3 over square root of 3. So I get y equals 8 times the square root of 3 divided by 3. Now this makes sense. It does. It really, really does, because look at this. Notice the smaller side over here is half of the larger side. So if I have 16 times the square root of 3 here divided by 3, then I should have 8 here, and I do. It makes sense. I like numbers. Numbers do not lie. Okay, for my final problem for this section, for topic 5-4, set up my triangle once again. Turn up the brightness just a little bit here. Okay, I'm going to set it up. 1, 2, square root of 3. Take LM, put my x there. So 4 times the square root of 3 is to x. So that's a hypotenuse and a leg. As 2 is to the square root of 3. Okay? I'm going to cross multiply. So I get 4 times the square root of 3 times the square root of 3 equals 2x. Square root of 3 times the square root of 3 is 3, so I get 4 times 3 equals 2x, which gives me 12 equals 2x. Divide by 2, and x equals 6. So side LM equals 6. Now side MN, just from eyeballing it, and we'll prove it with the ratios in a minute, but if over here this is 2 compared to 1, so 1 is half of 2, half of this is 2 times the square root of 3. Just a quick way of eyeballing it because I see the relationship. But let's go ahead for the fun of it, because math is fun, and set up our ratios of 2 is to 1. So I get 4 times the square root of 3 is to 2y equals 2y. Divide by 2, divide by 2. I get 2 times the square root of 3 equals y. So I just proved it mathematically, but I was able to eyeball it and say half of that is that. And thus I am finished. So once again, 30, 60, 90 triangles. Little bit different than 45, 45, 90 triangles, simply because I have different side lengths for the two legs. But I solve them exactly the same way. I deal with radicals in the same way. I solve them the same way. Everything is happy, happy, happy. All right?